Guided practice 9. F of x equals e to the x power all over x minus 1. A. Find the y-intercept. F of 0 equals e to the 0 power over 0 minus 1 equals -1. So 0, -1 is the y-intercept. To B, for what values of x is f of x defined? We know this is a rational function. X minus 1 not equal to 0. X is not equal to 1. And remember, x equals 1 is the vertical asymptote line. Domain is x not equal to 1. In other words, when x not equal to 1, f of x is defined. Find the sign of f prime of x and f double prime of x. Comment on the geometrical significance of each. First of all, we need to figure out f of x. F prime of x equals, we will use the quotient rule. U over v prime equals v squared as the denominator, u prime v minus u v prime. X minus 1 squared e to the x power prime times x minus 1 minus e to the x power times x minus 1 prime. Simplify. X minus 1 squared as a denominator, e to the x power times x minus 1 minus e to the x power. We will take e to the x power as common factor. E to the x power is the common factor, so we take out x minus 1 minus 1 over x minus 1 squared equals e to the x power times x minus 2 all over x minus 1 squared. Let's draw the sign diagram. For the root, x equals 2. We know e to the x power always greater than 0. For the vertical asymptote line, x equals 1. Vertical asymptote line, x equals 1. So get 1, 2. Vertical asymptote line. 2 is the root. Use 0 as the number to test the sign for each interval. Since f prime of 0 is less than 0, so negative. Since f prime of 0 is negative, so this is negative. Even power at x equals 1, so no sign change. Still negative. Single power for x minus 2, so we have a sign change. Geometrical significance. Geometrical significance. The slope of a tangent line on the interval -infinity 1 union 1 to 2. It's negative. The slope of a tangent line on the interval 2 to positive infinity is positive. Now let's work out the second derivative. Still, we will use the quotient rule. x minus 1 squared, then squared, e to the x power times x minus 2 prime times x minus 1 squared minus e to the x power times x minus 2 times x minus 1 squared prime. There is a general rule. If denominator is something squared, there must be common factor you can reduce. Since this is a really complicated derivative, you need to work this out first. E to the x power times x minus 2 prime. We have to use the product rule. U times v prime equals u prime v plus u v prime. E to the x power prime times x minus 2 plus e to the x power times x minus 2 prime equals e to the x power times x minus 2 plus e to the x power. So we will take e to the x power out. X minus 2 plus 1. Simplify. E to the x power times x minus 1. E to the x power times x minus 1 times x minus 1 squared minus e to the x power x minus 2. Let's work this out. X minus 1 squared prime. Power rule first. 2 times x minus 1 times x minus 1 prime equals 2 times x minus 1. So times 2 times x minus 1. Denominator x minus 1 to the 4th power. Reduce first. Denominator x minus 1 to the 3rd power. E to the x power x minus 1 squared minus 2 times e to the x power x minus 2. Then we need to take e to the x power out. Denominator x minus 1 to the 3rd power, e to the x power. X minus 1 squared equals x squared minus 2ab is 2x plus 1. X squared minus 2x plus 1. 2 times x minus 2 is negative 2x plus 4. So minus 2x plus 4. X minus 1 to the 3rd power. E to the x power. Simplify. X squared minus 4x plus 5. So for the root, since e to the x power always greater than 0, we need to solve x squared minus 4x plus 5. We cannot factor, so you have to use the quadratic formula. Let's work out b squared minus 4ac first. We know a equals 1, b equals negative 4, c equals 5. B squared is negative 4 squared minus 4 times 1 times 5 equals 16 minus 20 equals negative 4. Here is the rule for quadratic function. B squared minus 4ac less than 0, no real roots. B squared minus 4ac equals 0, only one real root. b squared minus 4ac greater than 0, 2 real roots. Therefore, for this quadratic function, no real roots. Since a equals 1 greater than 0, the graph opens up. Won't touch this x-axis because no real roots. And from this graph, you could say x squared minus 4x plus 5 will always positive. Then we need to figure out the vertical asymptote line for this function. X equals 1 is the vertical asymptote line. Now let's draw this sign diagram. Vertical asymptote line is 1. Since e to the x power always greater than 0, and no roots for this quadratic function, f double prime of 0, we plug 0 into this function. We got negative number. So this interval is negative. Take the exponent, odd power. We need to change the sign. Positive here. We can write down the geometrical significance of this second derivative. F of x is concave down for x less than 1 and concave up for x greater than 1. D. Sketch the graph of y equals f of x. F of x equals e to the x power over x minus 1. We already know f of 0 equals negative 1. And x equals 1 is the vertical asymptote line. This is a sign diagram for f prime of x. This is a sign diagram for f double prime of x. For x equals 2, going down and then going up. So, local minimum at x equals 2. When x equals 2, we will get e squared over 2 minus 1 equals e squared. E you can count as 2.7 or 3. X, y, origin. Get the scale. 1, 2, 3. 3, 6, 9. Now let's locate the points of vertical asymptote line. X equals 1 is a vertical asymptote line. E squared less than 9, 2e squared. So we will get this point here. The intercept is 0, negative 1, it's here. For this interval, negative infinity to 1, sign for the first derivative is decreasing. Based on the second derivative sign diagram, it's a concave down. Decreasing, you have this way or you have this way. Concave down will be this. Also from this function, we know no roots because e to the x power always greater than 0. Therefore, you can predict the graph like this. In this interval, decreasing and concave up. Decreasing either like this or like this. Concave up will be this. You can predict the graph like this. local minimum at x equals 2, you can predict the graph like that. E. Find the equilibrium of tangent at the point where x equals 2. We already figured out f of 2 equals e to the second power. We already figured out this first derivative. So slope of a tangent line equals f prime of 2 equals e squared times 2 minus 2 over 2 minus 1 squared equals 0. So the tangent line is the horizontal line. Therefore, y equals e squared is the equation of a tangent line. Or use this graph. We know local minimum point at x equals 2. Therefore, the equation of a tangent line will be y equals e squared.